Good afternoon and welcome to the Q&A session 26 from the playlist of Work, Power and Energy. The topic is the instantaneous power, and based on this topic I have one question for this session, which is written here on this board. So the question here is: a body of mass m is accelerated uniformly from rest to a speed v in a time interval t. So the instantaneous power delivered to the body as a function of time t is. So here we have four options and we have to select the right one. Now we know that the instantaneous power is equal to F into V, where F is the applied force and V is the velocity. Now this F can be written as m, where m is the mass, into acceleration into V. Now here we have to find the acceleration of this body. Now since this body is accelerated from rest to a speed v in a time interval t, so acceleration will be equal to, this is equal to change in velocity divided by the time interval. So the change in the velocity is equal to v minus 0 divided by t, that is capital T. So this is equal to v upon capital T. So instantaneous power, say P, is equal to m into v upon t into v. Now we have to find the correct option from these four. So from here we can see that the options which we have, they are in terms of the mass, velocity, the time interval capital T and the time t. So here what I will be doing is, I will simply substitute the value of velocity as acceleration into time, because acceleration is equal to velocity upon time. So v can be written as a into t, and so the instantaneous power can be written as m v upon t, but now a is equal to v upon t into t. So the instantaneous power will be equal to m v square upon t square into small t. So here the correct option will be mv square upon t square, mv square upon t square into t. So the correct option here is A. So thank you very much for joining this session. In the next session I will be coming up with a different topic from the same chapter of Work, Power and Energy. So till then, have a nice day. Bye.